Codebook. So today we'll discuss about the array. We'll discuss everything about the array. Right. So before talking about the array, let me take you to the editor and identify what is the need of array. Why we require array. So consider we need to store few roll numbers of a student. Like suppose there are two students in a class. Suppose, right? So we can have roll number one as one. So we can have roll number 2 as 2 and so on. And suppose we need to store 100 element, 100 rule numbers. So now the problem arises, right? We need to define 100 variables into that. So this has become tedious for us to write. So here it comes the concept of arrays. So in array what we'll do, we'll create a linear collection of element through which we can access the element, we can store all the elements into that, and we can access the element from that also, right? So let me discuss the array. So array is, by definition we can say that array is a homogeneous collection of items stored as a contiguous memory location. What does it mean? I'll come up to that. So suppose we need to store the previous example only. We need to store the roll numbers of all the students, right? Starting from 1 to 100, right? So we need to before that, before array, what we need to do? We need to have 100 elements, right? And then we'll store into that. So with the array, what we can do, we can initialize an array of homogeneous type, like the roll numbers. Suppose the roll numbers are in integer only, so we'll define an integer of array of 100 size, so that it will, all the elements of arrays are stored into that, and that are of contiguous memory location, so we can directly access that element by their index. I'll come to the index also. So for simplicity, we can also term array as a group of variables of same data type, right? It is a group of same data type. It is an organized structure, simplifies the manipulation and retrieval of data. Through that, we can easily manipulate our data and retrieve our data easily. But there are some limitations also of the array. So arrays are fixed in size, right? Before creating an array, we must know the size of the array. It is not like we can create an array of any size. Suppose I'll create an array of 10,000 size, right? And in there, I need to store only 100 variables. So the size of are of no use, right? There is wastage of memory. And then there in further lectures we'll discuss about vectors also, how vectors resolves this issue and all. But as of now, this is the issue with the array, right? Array allows us a random access through which we can directly access the element, right? Suppose we need to access third element, we can directly go to by their indexes. Now we'll discuss about the declaration and the initialization of array. Right. What does declaration mean? Declaration means to declare a name of something, right? Suppose you are person, right? So you have name, right? So there is a declaration to it, right? So in array we'll declare an array just by giving its data type, the identifier, the name which it should resembles, and we can also give the size of the array, right? All the values are initialized to garbage values, right? Because we haven't initialized anything to the array, so by default there will be a size of 3 ARR, and all the values are garbage values. It can be anything, right? So then the second thing comes up, the initialization of the array. And initialization is just basically initialize the array at the start, at the declaration only, right? So what we'll do, if you see the example here, so what I had did, I had created an array of size 3 and had initialized its value also, ARR of 3 of 134. Now we'll discuss about the memory allocation and the indexing of the array. So memory allocation is just basically mean to allocate the memory of array. So the memory allocation for array is done at the compile time. When we compile our code, the memory is allocated to an array. The size of the memory is determined by the number of elements in the array and the size of element based on its type, right? Suppose we need to declare an array of size 3, right? What will be its size of the whole array? So it depends upon the number of elements in it. That is, for our case, it will be 3, and also the which data type. Suppose integer, and 64-bit integers will have 4 bytes. So in 4 into 3, that is 12. So if we can we will define array of size 3 of integers, it will have 12 bytes, right? And it is allocated to the compile time only. Now we'll come upon the most important thing, that is indexing. Indexing indexing is, in simple term, element in an array are accessed using by their indexes only. So we suppose we need to access an element in an array. How will you identify that element, right? So for that, indexing comes into the picture. And suppose we need to add get the third element. Yeah. And before that, keep into the mind that indexing of arrays start from zero only. In most of the programming, indexing starts from zero only. This is because um, okay, we'll discuss some in later part, or we can discuss now also. Okay, so because suppose for accessing any element, the formula will be base address, the starting address of the array, right? That is the base address plus size of the data type we have discussed before that, and to the index, what index we have to identify, right? And you all know about computers and all, and memory. The minus operation is not performed directly, right? For that we need to have take two's complement and all. So this is an expensive operation for in terms of time and all. So for this what we'll do, we had just instead of doing -1, what we'll do, we'd start the index from 0 only. So for the first element, it is at the 0th index, then first index, then second index, right? This so onwards. So suppose the base address will be the 2000 for the above array, and the size of integer will be 4, right? And we need to get the fourth element, that is the third index, right? So if we go by this formula, so 2000 plus 4 into 3, so that will be 2012. So if it is at the 2000s position, so that will be at 2004, 2008, 2012, right? That will be our 4 element, so it will be 4, right? In that manner, we'll calculate the random access of the element in an array, the array, right? So there will be one dimensional array, two dimensional array, and the three dimensional array, or multi-dimensional, we can say. From two dimension onwards, we can say the multi-dimensional arrays, right? So we have discussed one dimensional array, right? So the linear collection of data. So the syntax will be the data type, identifier, the length, and the list of item. As we have here, we can see the example, right? We have an integer of array of size 3. For accessing an element, we'll use the indexing, and we know the indexing starts from 0 onwards. So if we want to get the first element, what we need to type? We need to type ARR of 0, right? So that will give the first index, first element at index 0. So suppose if you want, I want to try ARR of 5. That does not exist, right? So now what will be the case? So do we get out of index error? Okay, I just missed. Or we can get some garbage value. Okay. So if we try to access an element which is out of index, right? In case of C, we'll get the garbage value. We'll not get any error. We'll have something random values, right? So just keep in mind this might be in an interview someone asked you, right? Suppose if in C will access the element which is not in the array, so what we'll get? We'll get the garbage value outside of the array, right? So here we can see that the zeroth index, 1 index, 2 index, 3 index, 4 index, and 5 index, and these are the elements, right? Okay. I'll do practical also for that. First, I'm thinking of I'll cover the theoretical when we'll come to the practical part, right? Okay, the two dimensional is just basically we need one dimensional. We have the limitation, right? We can only store in a linear format. Suppose our data is in matrix format, we can say, right? We can see matrix format. So how we can store the data, right? So for the two-dimensional array comes into the picture. You know about row and columns. I hope you all know about the matrix, right? It's a two-dimensional thing. 2D array, right? I'm talking about 2D matrix only. So int arr of we can define the same type. So int arr of 3. This is the syntax for the data declaration and initialization both. So int arr of 3 if they want to access something, right? We want to access 30. So what will be the row? So then first the row, so that is 1, of 1, right? So if I discuss 1 of 1, I'll get 30. Then I have 0 of 1, so that will be 0 and that will be of 1, so I'll get 10, right? And I have 0 of 2, so 0 of 2, right, is 20, so I'll get 20 from here, right? Okay, now let's go to the code editor and have some practical. So let's start with some practicals also. So we know array, right? So we know how to define an array or declare an array. So what we'll do, what I'll do, I'll store 5 element in an array, and what we'll do, we'll perform some operations on the array. So suppose we'll declare an array of ARR, and we must know the size of the array initially only, right? Before declaring it. So suppose 5, and what I'll do, I'll initialize the array also, 3 and 4 for simplicity, right? And we want to access the first element at index. So modulus is for integer only, so I'll just access of first element. So what will be the output, right? So if we go through what we have understand, so ARR of 1, that means the element at 1th index, right? So it comes 2, so that answer will be 2 only. Okay, I had just missed the printf, right? Okay, I'll give backslash n here, so we'll have a new line. So element at ARR of 1 is 2, right? So that is the, we can say, accessing the element, right? So in that manner, one thing we also understood, right, from our previous theories, right? Suppose if I want to access the element which is not in the array, if I want to index ARR of 5, right, it is not in the array, so then it should give some random value. That's what we have learned. So it is giving, as of now it is giving 0, but it can give anything. Okay, let me try for 4. It can give anything, right? So it is not mandatory that if it will give 0 only, it can give anything, any values it can be. Okay, let me copy this so it will be handy for you also. So that will be a garbage value. Okay, so now suppose we want to insert an element in here, and suppose we want to insert at the second place only. So what we'll do, so we can just directly write an element to that index. So I want to insert at element 1 and the value will be 100. So again, so now it will give 100, right? Or I will have 100, 2, 3 and 4, and array will become 100, 2, 3 and 4. Now what we'll do, we'll traverse the array. You all know about loop. So what we'll do, integer I of 0, then I of less than 4. Now okay, we know as of now the size is right. So what I'll do, we can type space and then the array of I. So it will print the array, right? So it will print 100, 3 and 4. Okay, sorry for that. That will be the second index has been changed. Okay, I changed the thing. Sorry for that. Now comes to the traversing, right? So here we know the size. Suppose we want to get the size of the array, right? Okay, we want to know the size of the array. So what will be the size? Size will be, so we have a size of operator, so we can have size, suppose n, or a size we can have a size of operator. So size of operator, what will be the ARR? So what it will give? It will give the whole size, right? But what we need to do, we need to know the number of elements. So what we'll do, we'll just simply divide by size of ARR of 0. The total size divide by the size of data type, that gives us the size, right? Suppose the size of the whole array is 16 and one integer comprises of 4 byte. So now it comes the 4, right? So size will be 4, right? So same in that manner for integer I of n, I less than n, I plus plus, and then what we'll do, we can print our array. Okay, what I had just missed. Okay, that is not n, that is the size. Okay, I'll do printf line change so that it will be easier for you to understand. Right, that is 103 for the same. Right, you can also see that. Right, the ARR of 4. The second thing, we are getting garbage value. Right, it can be anything. So now we are getting -7 and something something. So it can be anything. It can be anything. No, we cannot predict what will be the value of garbage. It can have anything. Right. So we have covered insert, delete. Okay, delete is remaining. Accessing the element, inserting, deleting, traversing, size. Right. So the one thing is left is, suppose there's one operation of deletion. Okay, deletion I'll cover. Okay, suppose we want to delete an element in an array. Right. So for that, what we need to do in C, what we have to do, we have to shift all the elements by one and decrease the size of array. Right. Suppose I want to delete ARR of index at 3. What I need to do? ARR of 2. So I need to delete this 2. So what I need to do? I need to shift this 4 to this 3's place and decrease its size by 4. So it will become 1, 2, 4. And it will become 3, but what we'll do, will decrease the size also, right? So initially the size of 4, then it will become the size is 3. For that we need to have integer of this formula we had need to define earlier, and we need to decrease the size by 1. Size is equal to size minus 1, then we'll get the size as 3, and that manner we can use. There is also some functionality of creating a dynamic array. Dynamic array, right? Suppose this is the fixed, right? This is 4, this is 10, but suppose I need from user some size, right? User will enter 5, user will enter 10, user will enter 100, user can enter anything, right? So for that we have calloc malloc that we'll discuss in some other videos. So there is a functionality called malloc calloc that is used to define an dynamic array, and there is also a free method in it through which we can delete. So that will become easier for us to delete an element in an array of dynamic type. So that supports free supports only if the array is of dynamic type only. Right. Okay, is there anything left? No, I think everything is covered. Yeah. Thank you, everyone. Okay, now we'll discuss something more about arrays. What are the advantages? Right. We have discussed previously. So array have a random access to element, right? We can access directly that element, right? We just not need to traverse one by one element to access that element, right? Suppose if we need to go the fourth element, we can directly go through by ARR of 3. If we want to go the fifth element, we can directly go of ARR of 4, right? But that is not in case of linked list, right? For linked list we need to traverse one by one only. We can group multiple data of same type that we have also discussed. Suppose we have to store roll numbers, so we can create a group of collection that is known as an array, and it is used to implement some other data structures like linked list queue, etc. Yeah, thing that we need to discuss is the disadvantages of array. So there's disadvantages like arrays are fixed in size. We plan before declaring. We prior need to know the size of the array. Arrays are homogeneous collection of data. Suppose you want to store heterogeneous collection of data, right? So it can have integers, it can have string. That is not possible in arrays, right? And then arrays store the memory in contiguous memory location. So through which there are few things that are difficult to implement, that is insertion and deletion. So suppose if you want to insert in between that element, so what we need to do, we need to shift all the elements by one, right? And same for the deletion also, that will become tedious. And to overcome this picture, the linked list comes into the picture, right? I guess we have covered everything. So okay, now uh, one thing what we can discuss in arrays, what are the important questions or interview or important things in an interview, what the interviewer can ask to you, right? So I'll come to that. So first, the basic thing is what is the introduction to arrays, right? First thing. The second thing can be the memory allocation. What is dynamic arrays that they need ask? They can ask, right? Um, we haven't covered that thing, but that will cover in some later videos. That, right? I had uh, give a glimpse of Calloc Mylock, right? That is the things come into the picture. If we'll talk about the dynamic arrays, right? So one of the famous questions that asked is why indexing starts from zero, that I has discussed. And the other thing, what an interview can ask in an array is the time complexity of any operation. Okay, that I think I had missed, right? Time complexity. So if we'll talk about the time complexity for the insertion, what will be the time complexity? We have to insert an element. So that might be possibility with we need to shift all the elements in the array, right? So the insert, okay, inserting element, the time complexity will be big of n. For deletion will be the same. Insertion or deletion will be the same because we need to shift the element. It might be possible we need to shift the whole element at max, right? So the time complexity will be big of n. Okay, and then the time complexity for traversing, we need to traverse the whole array. That also becomes the same. Traversing all elements becomes the big of n. Okay, so the time complexity for accessing, so that will be big of 1, right? Because we can directly access that element. Suppose we want to access the fourth element, we can directly go ARR of O minus 1, that is 3. So we can directly access that element. So the indexing is okay. All right. So time complexity I had discussed, introduction, memory allocation, dynamic arrays. Right. One thing that interviewer may ask, but I haven't covered till now, is difference between arrays, list, and vectors. Vectors in case of C only, C++. It is not in the C. So arrays we have in C, list and vector we have in C++. I think that's all. There are some important questions we can in which interviewer can ask to you. So be prepared for that. Please let me know anything else